All right, so the first question, you want to identify the vertical asymptote and the horizontal asymptote. So the vertical asymptote will be this axis over here, as you notice, and you can focus on the intersection of the axis with either the x or the y. And you notice here this is x equals to -1, so the x-axis equals to -1. Therefore, this line is going to be x because it's intersecting the x's, and it can be -1 because it's intersected at -1, and this should be your equation of the vertical asymptote. Now for the horizontal asymptote, and the horizontal asymptote, it would be this one as well, to see it, and we're going to do exactly the same thing. So we're going to look what axis does this line intersect, and obviously it will intersect the y-axis in this point, and that point is -2 here. So an equation of this line will be y equals to -2, and this is going to be the horizontal asymptote. So always you want to look for the intersection, right? Now moving on to the x-intercept, and we want to see what part of the graph is intersecting the x-axis. So the x-axis is this one, as we mentioned before, and we notice only this section of the graph. Only this section of the graph intersect the x-axis in this point, and that point here is -3, x equals to -3. So this is not an equation, right? So this is a x-intercept. X-intercept is equals to -3. All right, or you can write it down -3, 0. All right, so either notation would be okay. And we do the same fashion way. So we are for looking for the y-intercept, we're gonna look for only this portion of the graph will intersect the y's. The y-axis is the vertical line, and the point where the y-intercept is going to be equals to -6. All right, so this point here is actually 0 -6, right? So 0 -6, it means the y-intercept is going to be -6, or you can write it down as 0. Now for the third question, and the way we proceed about the domain range is by doing the projection. So the domain here is equal to the projection of the graph on the x-axis. All right, so if I do the projection, you notice that this part of the graph would be projected here. It will cover everything from there, and the projection of this graph here is going to be right here, just before the asymptote, and this part is going to be projected here, so you're going to cover everything here. So everything going to be shaded except the point at the asymptote here. So if I zoom in and look at my domain should be from -infinity all the way to -1, and then starting from -1 again and goes all the way to +infinity. So how can I write this down? The domain can be equal starting from -infinity going to -1, and then restarting from -1 going to +infinity. You notice here I did not take -1, it's open both sides, so I'm going to put a union between them, right? And the range, we're going to do something very similar. It's going to be the projection of the graph on the y-axis. All right, so if I do the projection on the graph on the y-axis, so we're going to have exactly similar scenario. So the projection of this part here is going to be right here, the projection here. So this is the shadow of the graph. You're going to cover all this part, and similarly here the shadow of this part is going to be projected here. All right, you have to go all the way to the y's actually, so you're going to cover everything in here, right? I think, and you can see only this point here is not going to be having a shadow, so everything else is having a shadow. All right, okay, so that's, if I if I read it, so it's going to be from starting from minus infinity from the bottom, it goes all the way to -2. Remember, this value is -2, and then restarting from -2 and going all the way to plus infinity. All right, so this is your range, minus infinity to -2, open, and open again from -2, going all the way to plus infinity, and you put a union sign on them, right? Okay, that's all.